As we know, all teams were asked to investigate the first part of the problem, some questions. The first question: investigate and demonstrate how to calculate the length of a circular arc. Okay, we have two formulas. When theta is in radians, then it's theta times r, and when theta is in degrees, then the arc length is beta times p over 180, that in the parentheses times r. Okay, second question. Our question says, using the formula, demonstrate the definition of the radian unit. Okay, as we know, the radian unit is a unit of measure for angles. Easy. And it's used mainly in trigonometry. We're in trigonometry with Ondina, and the radians are used instead of degrees, and 360 degrees are 6 radians. Okay, so let's say this circle is 360 degrees, and that's the same as 6 radians. Number 3 says, investigate and demonstrate how to calculate the area of a circular sector. Okay, this is our formula to calculate the area of a circular sector, and we have to do an example. For example, we have a central angle of 60 degrees, which will be this number here, and a radius of 10, that will be this. Okay, so we do the procedure with our calculator and all those stuff, and we have that our answer is like you divide 360 by 60, you multiply 100 by 3.1416, and you get that. Okay, number 4. Number 4 says, explain the concept of angular speed. How does this relate to linear speed? A vector quantity describing an object in circular motion. Its magnitude is equal to the speed of a particle, and the direction is perpendicular to the plane of its circular motion. The angle, angular velocity, and angular acceleration are very useful in describing the rotational motion of an object. Number 5. The question says, write the formulas needed to calculate linear and angular speed. Okay, so for linear speed we have v equals s over t, and for angular speed w equals x over t. I love you, Ondi.
We were asked to solve 2 problems. So first, we are going to solve number 67, travel distance. Can somebody read the problem?
Me. 67. Travel distance. A car's wheels are 28 inches in diameter. How far in miles will a car travel if its wheels revolve 10,000 times without slipping?
So here's our data. C is the circumference of the wheel. That will be the formula P times diameter. D, car's wheel diameter, that is 28 inches. R, that are the revolves of the wheel, that is 10,000 times. And M, that means the distance in miles. So now we need to find a formula to solve this problem. So we search for a formula in the internet and we found this one. That means miles is equal to revolts times circumference. That will be so this is our formula. And the result of this formula, you need to remember, that will be in inches. But they ask us to find the result in miles. So after doing this operation in the calculator, you need to make a regla de tres to pass it to miles. So we solve this operation, and the result is this is the result of this parenthesis, and then the final result is inches. So the result we need to pass it 2 miles. So here we made regla de tres. We need to pass inches to feet and then feet to miles, because this is impossible. Inches to miles is impossible. So 1 foot equals to 12 inches. 879,645 inches, how many feet will be? So here we multiply this times 1 foot divided by 12 inches. So here we have the result in feet, and then from feet we need to change it to miles. So we know that 1 mile equals to 5,280 feet. So this result, how many miles will be? So we multiply the results times 1 divided by 5,280, and the result is 13.88 miles. So this is the distance that the car travels.
Hello dear students, today we're going to see problem number 31, orbit of the Earth. Someone wants to read it?
Me! 71. Orbit of the Earth. Find the distance that the Earth travels in 1 day in its path around the Sun. Assume that a year has 375 days and that the path of the Earth around the Sun is a circle of radius 93 million miles. The path of the Earth around the Sun is actually an ellipse, with the Sun at one focus. This ellipse, however, has a very small eccentricity, so it is nearly circular.
Well, we have here the data. We know that a year has 365 days. And the problem gave us the radius of the Earth, that is 93 million miles. And the last one, we need to know the eccentricity of the Earth. We look for it at the book, and it's 0.017. Well, in order for us to get how many distance the Earth advances per day, we need to get A and B. to know what's the perimeter of the ellipse and then know the distance of a day. So the problem gives us the radius, that is 93 million, that represents A. A is equal to 93. And the other distance that we need of the ellipse is B. We have A. So we know it. And with the eccentricity, we can know, with the formula of eccentricity, we can get B. So we start, E is equal to C over A. C is equal to A by E. We substitute 93, that is A, 0.0017, and it's the eccentricity, and that will be equal to C. C is equal to 1.58. Now, with A and C, we can use another formula to get B. That is what we are looking for. So B squared is equal to A squared minus C squared. B squared is equal to 93 minus 93 squared minus 1.58 squared. This will give us 8,646.51 square root, and it's 92.98. This represents B. That is the distance that we were looking for. Now that we have B, using an ellipse calculator, with these two values, we get the perimeter. That is 583.972. But we don't want the perimeter. We have the distance per day that the Earth advances. So we divide this by 365, are the days in a year, and the result will give us 1.6 million miles. And this is our distance.
As a conclusion, we got two final results. For the first problem, we got that the car traveled 13.88 miles, with its wheels revolving at 10,000 times without sleeping. And for the second problem, we got that the distance that the Earth travels in one day around the Sun is 1.6 million miles per day. This type of formulas and problems can be applied in different situations, such as the distance that a car travels around the city, or it also applies for solving how many miles will a person travel all around the world. We use it to measure distance after a certain time or a certain limit.